Okay, one of my great students asked me to show her how to do this question. Uh, it's the integral of 0 to 5 of 3 minus x with an absolute value dx. So I'll go ahead and explain it here so that she and everybody else who needs help with it can take advantage and benefit from this video. So the integral of this function has an absolute value. So the answer or the way we're going to approach this will depend on what's the absolute value of the function 3 minus x. So let's go ahead and write that first. So 3 minus x absolute value, okay, have to be evaluated as two separate functions depending on what x is. Because technically in math, when you say the absolute value of x, you can either mean x or you could mean negative x. If x is positive, like might be easier to just you say the absolute value of x in math, that just means you could mean x if x is greater than 0, but if x is less than 0, since x is negative and you need to take it outside the absolute value, you add a minus sign and it becomes a minus x. So this is the absolute value of x. So in a very similar way, we will evaluate this. So this will depend whether 3 minus x is greater than 0, then we can just remove the absolute value without doing anything else by just saying this is equal to 3 minus x. But then if what's inside the absolute value is less than 0, then you multiply what's inside the absolute value by a minus sign. So it becomes minus of 3 minus x. Now, this statement here, uh, 3 minus x is greater than 0, I can solve it one more step by adding x to both sides. So I can say this is 3 greater than x. Or said in a different way, this is the same thing as saying x is less than 3. So basically what I'm claiming, if x is less than 3, then the value of this absolute value function will be 3 minus x. And with the same exact logic, I can solve this one here. So I could add x to both sides and I would get 3 less than x. And this is the same exact thing of saying x is greater than 3. So when x is greater than 3, the value of the function becomes minus 3 minus x. So right at 3, the function actually changes. And because 3 is included in the bounds of the integral, to be able to evaluate this integral, because it's different functions whether x is greater than 3 versus if x is less than 3, we would have to split this integral into two separate integrals. So then 0 to 5, 3 minus x dx becomes, if x is less than 3, so if we are going from 0 to 3, just like we got, the value of the function is 3 minus x. So we replace the absolute value of 3 minus x by 3 minus x dx plus, now as you guys know, one of the properties of the integrals is we can split the integral into two separate integrals. If we're going from 0 to 5, we are adding areas. It's the same thing as saying 0 to 3, the area from 0 to 3 plus the area from 3 to 5, because it's just the added area under the graph. So from 3 to 5, however, here on the second bound, so basically as long as you end and start with the same bound, you can always split the integral this way. Now, from 3 to 5, if x is between 3 and 5, that means x is greater than 3, and now the function is actually minus 3 minus x dx. And so now there's no more absolute value. So we the integral of x is x squared over 2, and we will evaluate this from 0 to 3, plus Here we have a minus, so we can first FOIL this minus sign in, distribute it, so minus 3 plus x. And the same way, we can just integrate. Minus 3 becomes minus 3x, and plus x becomes x squared over 2. And we will evaluate this from 3 to 5. And now the rest is fairly straightforward algebra. So we plug in the upper bound first, the 3. So this becomes 3 times 3 minus 9 over 3. In the 0, so minus the lower bound, but 0 will just give us 0 because if x is 0, 3x is 0, and same thing for x squared over 2. So this takes care of the first part, plus now we will do the second part. Not sure what happened here. This got okay. Here we go. We're back on track. So we will do the second one. Plus, just have pushed something by mistake here. So we put the lower bound first. This is a 3 here. Let's make it clear. So put the upper bound first. So that's minus 15 plus 25 over 2 minus. Now we plug in the lower bound, the 3. So that's minus 9 plus 9 over 2. Oops, this is a 2, not a 3. Okay, and that does it for the second part of the integral. And now we just figure out what this is. So we get this one is 9 minus 9 over 2 plus plus 25 is minus, so this is the same thing as minus 30 over 2, so that's minus 5 over 2, and then 9 over 2 minus 9 is minus 9 over 2, but then there's this minus sign here, so this is plus 9 over 2. So this 9 over 2 and this 9 over 2 cancel out, and we are left with 9 minus 5 over 2. And again, common denominators, so this is 18 over 2 minus 5 over 2. And our final answer will be 13, let's write it here, 13 over 2. So as expected, this is a definite integral, so we do get a definite answer when we evaluate this integral. So that means the integral of 3 minus x, is it 3? Yeah, 3 minus x from 0 to 5 turns out to be overall 13 over 2. I hope this helps. Sorry it took me a bit long to get to this. It was absolutely crazy. So just got around to it now. And thanks for watching.